Okay, today we're going to talk about CAD design of a Rudy the Robot, the Remco robot, which I recently did some videos on. And it's such a large robot that I thought it'd be fun to design and 3D print a version that's much smaller. In case you didn't watch the Rudys, I'll put a link down below, but basically here's the one that I used for measuring. And I basically took all the measurements off Rudy and then divided them by 2.5. So this will be version V2.5 of Rudy. And here we have a little, let's see, select this, let's hit that. And then I can rotate this thing around any way we want. So this is what we're talking about. But we got to break it down into the individual pieces so that we can 3D print them. I'm planning again on running this on a single AA battery and having an on-off switch here. As you can see, Rudy is a clawfoot walker. Being much smaller, there's no way this needs all 3 claws on each foot, but being that I'm just copying the original toy, it will have that. And the original toy had stickers everywhere, so I went ahead and made them physical properties for detail so we wouldn't have to be dealing with stickers. I would like it to have the moving arms plus the walking, and probably put in 3 flashing LEDs there. Now what I provided down here on the original Big Rudy, this is the battery box, and up above it is where they have the reversing switch, so when Rudy bumps into something going forward, then it walks backwards, and then the back side, when he bumps into something, then he walks forwards. But since I'm not putting the batteries down there, I'm going to leave this space open so that I can put some sort of reversing switch down there, which I haven't worked out in its entirety yet. Okay, let's see, what do we want to talk about first? Let's look at the body back. So this is the back of the body shell. Like I say, the battery is going to go there, the switch is going to go there, and hopefully the reversing switch mechanism is going to go there. And the inside, I have a captive area for holding the TT gear motor. I'm going to use the 1:48, or as we like to say in America, 48:1 gear ratio, which is the most common. And the arms will come through here. The switch would mount from the inside there. These are going to be ramps for the tops of the legs. The legs are going to meet on cams on the gear motor down here, and then they need a place for the post to rest for the angle of movement. So there's the back. Let's take a look at the front. Here's the front. We've already seen it in the larger one from that view, but on the inside, as you can see, there are 2 things to help retain the gear motor in place. There's also a block which will push against the gear motor to hold it in place, and instead of the neck opening being completely open, you can see the neck opening is partially closed. That's going to push down on the end of the gear motor. That way the gear motor is completely captive, cannot move in there, and I don't have to worry about trying to screw it in or anything. It can just sit in there. And you can see the holes for the LEDs I'm planning using will be the standard 3mm LEDs. And here's your pivot post points in the front part. As you can see, I have worked in screw tabs on the back and the front. Screws will go in from the back so the body can be screwed together. I don't have to glue it, because I figure I'll be taking it apart a lot trying to get things working. Arms. The right and left arms, of course, are inverse of each other, but this would be the right arm. It's going to have a post that's going to go in there and then into the body to hook up to the linkage that makes it move. And I'm planning on taking a number 2 screw through there to hold the arm onto that arm post. And let's see, what else have we got here? What's this? Oh, this would be the head. This is the top of the head, the front's facing up. Here's the bottom of the head. This is the neck hole, so this would be a part that would be facing down typically. You can see here's the lower part of the mouth that we saw, and here's the upper eyes with their lightning bolts. So basically this piece would flip around and nest onto that typically. And it's going to be hollowed out because up in the head I plan on putting the voltage the boost converter, where I want to change the 1.5 volts up to 5 volts so that I can run the LEDs in the chest, the flashing LEDs, but I may also need that 5 volts to control the forward reversing action, because there's a couple of ways I could do the switch. I know I'm not going to be able to do it completely mechanical because the robot's too small, doesn't have the mass and inertia that the big robot did to do a double pull, double throw switch. Okay. So this is part of the mag switch that I'm planning on possibly using. There's going to be a metal shaft that runs all the way front to rear, just like the original toy had, and this shaft would pass through here. And I've made 2 holes so I could put small magnets, 3mm by 1mm. They're small, but it's a common size. And I don't know whether I'm going to need magnets in both holes at this point, or just one hole. I don't want it to stick so strong that the robot can't unbreak. Well, basically my thought is I'm going to take a piece of tin and wrap it around here and possibly here. I don't know yet, but I left that open in case I need to. Drop a magnet in which would stick to the tin. Then this side of it would push against another contact and the magnet should hold them together, and that would secure the reverse walking action. And once it bumps into something, it has to be able to push that away so that it's no longer sticking to the other piece of metal which made my contact to walk forward. Anyway, that's my plan. We'll get into more detail on that later, because that's going to probably change. Right arm linkage. So here's that post that goes out to that arm, where the screw would go through the arm and hold it onto this post. And this is going to go down to a cam, same cam that makes it walk. And that'll make the arms swing. What do we got here? Well, we got one of the feet are symmetrical as well. So one file, you just print it twice. On the bottom I've made slots where we're going to glue the claw toes in. That way this thing can print flat like you see like this with no supports. The cam that makes it walk fits through that big hole. This rests on those posts that I showed you up inside the body, front and rear, to work as the pivot point. So what have we got? That was a foot leg. We've got, well, here's the cam. So this cam will push onto the TT motor, this part going towards the TT motor, and when you print it the way it's sitting, so the support material would be back here. So when you pull it away, if that edge is rough, it isn't going to make any difference. These edges out here we all want to be smooth. This large cam is the one that's going to move the legs. This smaller cam is the one that's going to move the arms. And of course you would print 2 of those, one for each side. Bumpers. So there'll be a rod moving through the robot for the forward and reverse, and on the end of that metal rod, right now I'm planning on using a I'm going to use a 2.5mm rod, just because I've got some lying around. And these bumpers would slide on the end to give, so when the robot bumps into something, you have something other than a sharp metal rod sticking out. Make it look a little bit more finished. Here's one of the toes. We talked about gluing the claws onto the bottom of the feet. So this part here, you would put glue on those 3 sides and maybe the end and shove it up into the foot. And that would make the complete toe. I think that's it for the build. Go back to the assembled picture so you can kind of see the toes in place and how it should all look and fit together. And based on the size of an AA battery, you can get an idea that it's going to be a whole lot smaller than the original gigantic Rudy Tooty. Anyway, that's the plan. And there's the gigantic Rudy. And in case you need something for scale, this is what we're talking about. It's a big boy. For a plastic walking robot, it's a big boy anyway. Alright, keep posted on the project. When it's all done, there will be STL files on Thingiverse and printables, and then you can build your own version of the little mini Rudy.